All right, guys, this is the second video on this worksheet for Algebra 1, sections 2, 3, 2, 4. We already did the first page. Now we're going to do the second page, which is obviously more fun. We have equations with variables on both sides, equations that require simplification. What do I mean by simplification? Distributive property and combining like terms. And again, this video is intended for you not to be a copy machine, but for you to try to do the problem yourself and then actually watch the video. If you get stuck or if you are just completely lost, you watch the video for the explanation. It's a resource, not a means for you to copy the homework down and say that you finished it. All right, so let's begin with number 13. We have an equation. The b is clearly on both sides of the equal sign. So what we need to do is get rid of one of the b's. Again, you could decide to move the variable to the left side or to the right side. In this case, I'm going to move that negative b over to the right side by doing a plus b. And what I do to one side, I do to the other side. And of course, I want to put the b right below the other b because I could only add b's with b's. I can't add the b with 30. Those are not like terms. So what do I have here? I have 6 left over equals 5 plus 1 is 6 of those b's plus 30 comes down. So since I moved the b to the right side of the equal sign, I want to get the b by itself on the right side of the equal sign. So I need to get rid of the 30 and also this multiplication of 6. Let's begin with that plus 30 by doing a minus 30. If you have 30 and you owe 30, you'll have nothing left. What you do to one side, you do to the other side. 6 take away 30. It's like if you have $6, you owe $30, you will still owe $24. Bring down the equal sign, bring down the 6b, and of course that is 6 times b equals negative 24. Let's get rid of the multiplication of 6 by doing the opposite, dividing by 6. What you do to one side, do to the other side, divide by 6. Your final answer will be b on this side equals negative 4 on that side. Okay, and of course the better way of writing it would be b equals negative 4. But again, the idea is either one of those answers is acceptable. The b is alone on one side of the equal sign. That's good enough. B equals negative 4. Of course, I would write it like this, b equals negative 4. Let's move on, number 14. Let's get the x by itself on one side. Of course, I have x on both sides of the equal sign. So let's get the x's on one side. This time I'm going to take the 2x and move it over to the left side. So I am going to get rid of the 2x by subtracting 2x. Of course, that cancels out. What you do to one side, you do to the other side. 5x, take away 2x, is 3x. So I have a 3x, bring down the plus 2, bring down the equal sign, bring down the minus 10. Let's get that x by itself. I do not want the 3, I do not want the plus 2. Of course, I am going to get rid of the plus 2 by subtracting 2, and what I do to one side, I do to the other side. So these cancel. I now have a 3x left over. The equal sign comes down, and if you owe 10 and you owe 2, you're going to owe 12 altogether. What else do we have here? We have a 3 times x. I don't want that 3 times x, so I'm going to get rid of that multiplication of 3 by doing the opposite, dividing by 3. And what you do to one side, you do to the other side. So 3 divided by 3 canceled out. We ended up with just x, and negative 12 divided by positive 3 is negative 4, and we are done. Again, if you wanted to double check, you would just take this negative 4 and plug it into both x's and check and see if it gives you a true statement of equality, which it does. Let's move on to number 15. Step 1 on any equation is to simplify both sides of the equation first before trying to achieve your goal of getting x by itself on one side. All right, so we need to first simplify. Now, what does that mean? It's distributive property or combining like terms. If you have either of those or both of those, do that first, simplify first, and then worry about getting x by itself on one side of the equal sign. So we obviously have some distributive property. Take that negative 3, distribute it. Negative 3 times x is negative 3x. Negative 3 times positive 5 is negative 15. Bring down the equal sign. Distribute now the right side. Simplify the right side. 3 times x is 3x. 3 times negative 1 is negative 3. And that's about it, right? There's nothing to do on the left side of the equal sign. There's nothing to do on the right side of the equal sign. So we are done. Now what we need to do is get the x's by itself on one side of the equal sign. Obviously you have an x on the left side, you have an x on the right side. You don't want x's on both sides of the equal sign. You want to get rid of one of them. So I am going to get rid of the minus 3x by doing plus 3x. And what I do to one side, I do to the other side, plus 3x. What do I have next? I have rewriting it, I have a minus 15, let me go with black. Minus 15 equals 3 plus 3 is 6, and of course we're talking about x's. Bring down the minus 3. So as you can see, I had x's on both sides. I got rid of this one. Now I only have x on one side of the equal sign, which is the right side. So now I could worry about my goal, getting it by itself on that right side of the equal sign. So what do I get rid of first, the 6 or the minus 3? Of course, the minus 3. Do the opposite. What you do to one side, you do to the other side to maintain the balance, maintain the equality. If you owe 15 and you have $3, obviously you can't pay them off, but you'll still owe 12. Okay? And then bring down the equal sign, bring down the 6x. And that's obviously 6 times x. And you don't want a 6 times x. You want to get rid of that multiplication of 6. So let's divide by 6. And what you do to one side, do to the other side, divide by 6. Final answer here is negative 2. Why? Because negative 12 divided by positive 6 is negative 2. Equals, this cancels out x. So there's your answer. Negative 2 equals x. Or better said, I would write x equals negative 2. Let's move on. Number 16. So again, step 1 of solving any equation is to simplify both sides of the equation. And I recommend this. I would cover it up maybe with your hand, or like cover up the right side and just ask yourself, is there anything to simplify here? And what do I mean by simplify? Is there any distributive property and combining like terms? Yes, there's distributive property, and there's also combining like terms after distributive property. But if I asked you, is there anything to simplify on the right side of that equal sign? Well, is there any distributive property over here? No. Is there any combining like terms over here? No. So this is already simplified. The right side is simplified. Only the left side needs to be simplified. Okay. Sometimes both sides require to be simplified before trying to get the variable by itself on one side. So in this case, let's distribute 3 times a, that is 3a. 3 times 1, that is 3. And bring down this minus 5. Just bring it down. And that's what we have on the left side so far. Okay, we have 3a plus 3 minus 5. We have distributed. What's after distributive property? Combining like terms. Do we have anything that's alike? Yeah, we have a plus 3 and a minus 5. Those are numbers. You could combine numbers with numbers. So if you have 3 and you owe 5, you're still going to owe 2. So what we have here is 3a, I just brought it down. We said have 3, owe 5, you're going to owe 2. That's minus 2. Bring down the equal sign. As you can see, this is completely simplified. We already distributed. We already combined like terms. This is our simplified left side of the equation. Let's look at the right side, which there was nothing to simplify. It was already simplified. Let's just bring that down, 3a minus 2. So what we have here, guys, is 3a minus 2 equals 3a minus 2. Now, let me tell you this. At this point, I already know that the answers are infinitely many solutions. Or another way of saying that is a equals all real numbers. Okay. Now, this is a special case, and we talked about special cases on the video lesson previously, right? What do I mean by special case? Like, let's say we didn't notice that we had the identical value or identical binomial here equal to the identical binomial here. See, what this means, it's saying 3a minus 3a minus 2 equals 3a minus 2. Well, duh, this is identical to that. Of course they're equal, right? When are they equal? They're always equal. So some math books say identity as your final answer right there. I would rather you say a equals all real numbers, because it doesn't matter what you plug into a, you're always going to get a true statement that the left side equals the right side. Why? Because they're identical. That's why some math books say identity. Anyway, let's say you didn't recognize that. Let's say you just are so used to getting a by itself on one side that you continue working. You're like, oh, I want to get rid of this 3a by subtracting 3a. That'll cancel out. What you do to one side, you do to the other side. But what happens here? It also cancels out. So what do you have left? You have the minus 2 that came down. You have the equal sign that comes down. And you have this minus 2 that comes down. So this says minus 2 equals minus 2. Well, yeah, of course negative 2 equals negative 2. That's always true. So what do we say as our final answer? We say x equals all real numbers. Okay? It does not matter what you plug in for x. Oh, wait a minute. I should say a equals because we have a over here instead of x's. I'm sorry. Let's put a equals all real numbers. Okay? Why? Because it doesn't matter what number you plug in for a right here or plug in for a right there. You could plug in 3 and 3. You could plug in negative 50 and negative 50. You could plug in the number pi, the irrational number pi right here, and plug in the irrational number pi right there, and it'll be a true statement. The left side will equal the right side. How do I know that? Because if I solve it, I end up with something that's always true. Negative 2 equals negative 2. So that's saying that a equals all real numbers. And again, some books, and I'm not sure if our worksheet solutions actually write it, but sometimes they just write down identity property. Identity. I prefer a equals all real numbers. The value of a could be any number you want as long as you plug them into both, right? A could be 5, a could be 50, a could be all real numbers. That's a special case. And if you're still rough with that, please go back and watch the video on special cases. Number 17, as we could see, the right side says equals 36. That's already simplified. There's nothing to do there. On the left side of the equal sign, we're going to distribute. 4 times p is 4p. 4 times 3 is 12. Bring down the equals to 36. Let's get rid of that 12 by subtracting 12. What you do to one side, you do to the other side. Bring down 4p. That canceled out. Equals, this is 24. Final step would be to get rid of the multiplication of 4 in front of the p by dividing by 4 and dividing by 4. And you will get your final answer, p equals 6. That canceled, p equals 6. Moving on. Let's distribute 3 times 2t is 6t. 3 times 2 is 6. You know what, this is kind of weird. Let's make this t capital so I don't make the mistake of thinking it's a plus. So that says 6t plus 6. Then we have the equal sign. Then we have 18. All right, so we need to get t by itself on one side. We don't have t's on both sides. It's only on the right side of the equal sign, so let's get it by itself on the right side. I'm going to get rid of this plus 6 by doing the opposite, minus 6. What I do to one side, I do to the other side of the equal sign to maintain it equal. 18 take away 6 is 12. 12 equals 6t. Not 60, but 6 times t, right? How do you get rid of the multiplication of 6 in front of the t? You divide by 6. That cancels. What you do to one side, you do to the other side. And there's your answer. 12 divided by 6 really is 2 equals t. Of course, the better way of writing your answer would be t equals 2. Same thing. 2 equals t, t equals 2. Same difference. But I would write it like this, t equals 2. Let's move on. Number 19. Oh yeah, it's time for some fun stuff, right? Crazy equations, multi-step that require simplification, distributive property, and combining like terms with variables on both sides. Oh yeah, talk about having fun. You know, this is the kind of problem you want to just go to a party, you know, once COVID's over and there's actual parties again. Go to a party, you know, just turn on the lights, turn off the music, tell everybody to gather around. Tell them that you're going to show them how to solve multi-step equations that require simplification on both sides, that have variables on both sides. You will instant popularity guaranteed. All right. Anyways, let's do this. Let's focus in, and again, just for the sake of not getting overwhelmed, I'm going to cover up the right side of the equal sign. I want to pretend it's not there. I'm just going to look at this, and this right here says 5 times the binomial p plus 3 plus 9. I could distribute and I could combine like terms. That's exactly what I'm called to do. 5 times p, 5p. 5 times 3, 15. Bring down that plus 9. And now we have 3 terms. We've already distributed. Is there any combining like terms? Absolutely. We have a plus 15 and a plus 9. If I add those two together, I will get 26. No, 24. Sorry about that. Math teacher can't add. So we have 5p plus 24, maybe I should do this in black, 5p plus 24, the equal sign is right here. And now let's simplify the right side of the equation. Okay, so we already simplified the left side. You could kind of like block all this out and just distribute over here on the right side. There's distributive property and combining like terms. 3 times p, that's 3p. 3 times negative 2, that's negative 6. And we're going to bring down the plus 6. After distributive property, we're going to combine like terms. We have a minus 6 and a plus 6. What happens? Cancels out. You owe 6, you have 6. If you pay them off, you're not going to have anything. So on the right side, and notice I could see my equal sign right here. All I have left is 3p. I'm going to bring that down right there, 3p. So now we could look at both sides of the equation. And what we have here is the new simplified equation. What do I mean by simplified? It doesn't have any more distributive property or combining like terms. No more distributive property or combining like terms. This is simplified. Now we could worry about getting to the goal, to get p by itself on one side of the equal sign. Where's p at? The left side of the equal sign or the right side of the equal sign? It's on both sides. You don't want it on both sides. Let's get rid of one of them. So of course there's many roads to the same place. What you got to do is think about it. If you move p over here, then you'd have to get the 24 and get rid of it and move it over there. So that's more steps. Why not just get this 5p over here on this side, right? But then again, if you wanted to, you could go the other way. It's totally up to you. I am going to get rid of the 5p by subtracting 5p. That'll cancel out. What I do to one side, I do to the other side. 3p take away 5p. That's kind of like if I had $3 and I owed $5. I can't completely pay them off. I will still owe $2, 2 of those p's. The equal sign again comes down. The 24 comes down. Here's my new equation. 24 equals negative 2p. So that really is saying 24 equals negative 2 times p. I need to get rid of that multiplication of negative 2 by dividing by negative 2. What I do to one side, I do to the other side. And 24 divided by negative 2, that is negative 12. The equal sign again comes down. That canceled out. We have p equaling negative 12. There's my final answer. P equals negative 12. Moving on. Final question. The right side of the equal sign, it's just K. Wow, that's just one single letter. That is as simple as it could get. Now the left side of the equal sign, we definitely need to do distributive property and combining like terms. Let's begin. I am going to distribute the 2. 2 times 4, that's 8. 2 times 2, that is positive 4, and of course with the K. Bring down the plus 10. Out of these 1, 2, 3 terms, I could combine what's alike, the number 8 with the number 10. What is positive 8 combined with positive 10? We're combining like terms. Positive 8 with positive 10, that becomes positive 18. So let me rewrite it with the 4K first, because the positive 4K, you don't do anything with it. Just bring it down. 4K. 8 plus 10, we said, was plus 18, positive 18. And of course, the equal sign comes down, and we have the equals K on the right side. So, ladies and gentlemen, this is what we call a simplified equation. There's no more distributive property, no more combining like terms. Now you can move on to your goal of solving an equation. To get K by itself on one side of the equal sign, K is on both sides. You don't want it on both sides. So let's get rid of one of them. I'm going to get rid of the 4K by subtracting 4K. And what I do to one side, I do to the other side, subtract 4K. So I really have 1K take away 4K. I have $1. I owe $4. I'm going to still owe $3. In this case, I'm still going to owe 3K. The equal sign comes down. The 18 comes down. So this is really saying 18 equals negative 3 times K. I need to get rid of the multiplication of negative 3 in front of the K to get the K by itself on the right side. So I divide by negative 3. What I do to one side, I do to the other side. Divide by negative 3. And that'll give me my final answer. 18 divided by negative 3, that is negative 6, equaling, that canceled out, K. There's my answer, but of course I'm going to write it like this. K equals negative 6. And there you go, guys. This is the second video. This should complete the second page of this assignment that you have, or that you've had. Again, you need to understand this because we will have a test soon on solving equations.